A very good morning to all of you. Am I audible? Okay, in the last class we were discussing about the importance of pan coefficient. So whatever the values that you get from the pan evaporation values, it cannot be directly used because the surface area exposed to the atmosphere is very small when it is compared with a large reservoir or a lake or a pond. So in order to have more precise value, whatever the pan evaporation data values have to be multiplied by a coefficient known as the pan coefficient. So this pan coefficient, the value ranges between 0.6 to 0.8. So depending on the type of the instruments that you use, whether it may be a Class A land pan or ISA pan or a Colorado sunken pan or USGS floating pan. So the average value of the pan evaporation values, pan coefficient can be assumed in between 0.7 to 0.8. So you can take the average, that is 0.75. So in the examination also, in the given problem, if the pan coefficient values are not given, you can suitably assume it between 0.7 to 0.8. So or you can take the average value as 0.75. So for accurate measurement from evaporation pan, a coefficient is introduced known as the pan coefficient. So if you want to calculate the lake evaporation, so you have the pan evaporation values, whatever the instrument that you have set up surrounding that lake, you have the pan evaporation values. So it has to be multiplied by the pan coefficient in order to get the lake evaporation values. Now, these are some of the empirical formulas that are used to estimate the quantity of water or the amount of water lost to the atmosphere through the process of evaporation. So in the last class, we have discussed about these empirical equations. So the first one is the Dalton's evaporation equation. It is of the form EL is equal to KF U EW minus EA. And we have also discussed about the Mayer's formula and also the Rowe's formula. So in your syllabus, you have these three formulas. One is the Dalton evaporation formula and the Mayer's equation and the Rowe's equation. So most of the problems will be on either Dalton's evaporation equation or Rowe's equations or Mayer's equation. So next you have another analytical methods by which also you can estimate the amount of water lost to the atmosphere through the process of evaporation. So the analytical method for the determination of lake evaporation can be broadly classified into three categories. One is the water budget equation, this is energy budget equation, and the third one is mass transfer method. So these three methods, analytical methods, are very sophisticated method because too many variables are involved in this method in order to estimate the lake evaporation. So in your syllabus, this is not included. That is water budget equation, energy budget equation, and mass transfer equation. So these are the equations for water budget. And here you can see too many variables you have. So hence it is a specialist approach or a sophisticated approach. So water budget equation, energy budget equation, and also the mass transfer method or mass transfer equation. So these things are not included in your syllabus. So next is the reservoir evaporation. So if you consider a reservoir, so you can estimate the amount of water lost to the atmosphere through the process of evaporation. So the water volume lost due to evaporation from reservoir in a month is calculated by using the equation. So evaporation, that is the volume of water lost through evaporation, is equal to A into EPM into CP, where W stands for volume of water lost in evaporation in a particular month in million meter cube, and A is the average reservoir area during that month. That is the water surface area that is exposed to the atmosphere in meter square or in kilometer square, and EPM is nothing but the pan evaporation loss in meters or in centimeter in that particular month, because you have to install a ISA pan or a land pan or a Colorado Sunken pan in the vicinity of the reservoir. So whatever the values that you get from the pan evaporation value, it has to be multiplied by a coefficient known as the pan coefficient, and EL, here EL in millimeters per day into X number of days in a month. So you can calculate the evaporation, pan evaporation values in the vicinity of the reservoir, and CP is relevant pan coefficient. So by using this formula, you can estimate the volume of water that is lost to the atmosphere through the process of evaporation in case of a reservoir. Now next is soil evaporation. Soil evaporation. So who is this Redmi in Tayar Vidu? Hello. Who is this? Hello. Am I audible? ಯಾರಿದು ರೆಡ್ಮಿ ಅಂತ ಹಾಕಿರೋದು? ಹಲೋ, next is soil evaporation. So the evaporation from a wet soil soon after a particular rainfall. So the evaporation from a wet soil, because when a rainfall takes place, initially the soil moisture builds up and it reaches the saturation level, and the excess water moves down and joins the groundwater. So initially, soon after the rainfall, the soil surface, the top layer of the soil surface will be wet in condition. So some molecules of water escapes to the atmosphere through soil. So it is known as soil evaporation. So the evaporation from a wet soil soon after a rainfall or escape of water molecules with more resistance when the water table lies within a meter from the ground surface is called as soil evaporation, and it is always expressed in terms of percentage, and it is called as the evaporation opportunity. So evaporation opportunity is nothing but actual evaporation from the land or soil at a given time divided by evaporation from an equivalent water surface area. So multiplied by 100. So it is always expressed in terms of percentage. It is called as soil evaporation opportunity. Next is we shall discuss the methods by which you can reduce the evaporation losses from a reservoir or from a lake or a pond. So now, first thing is, in order to reduce the evaporation losses from a lake or a pond or a reservoir, so the first thing is reduction of surface area. That means constructing reservoirs with a minimum ratio of actual storage. That means in order to construct a reservoir, you should have whatever the surface area exposed to the atmosphere should be less in order to reduce the evaporation. And storing water below the ground. That means in case of some places where you have a reservoir within a reservoir, a small reservoir within a reservoir, so that you can store the water below ground. So hence the evaporation losses can be minimized. And storing water in one or large reservoir instead of having a small number of small reservoirs. So you can have one big reservoir instead of having a small reservoir, so that you can reduce the evaporation losses to some extent. Next, selecting a proper reservoir set. So this is most important. So if you select a deep gorge, a deep valley or a deep gorge, hence the depth of the storage increases, hence the surface area exposed to the atmosphere will be minimum, hence to some extent you can reduce the evaporation losses, and the straightening the stream channel, and thus you can reduce the water surface area exposed to the atmosphere. So straightening the stream channel means, suppose if the stream channel is having bends and curves, so you can straighten it so that the velocity of flow increases in the channel. So thereby you can reduce the evaporation losses to some extent. So the second method is, so by providing some mechanical covers in case of small ponds or small lakes, roofs or floating rafts, windbreaks, floating wax, floating lightweight concrete blocks, removal of plants near the water surface. So or else you can cover the water surface area by means of a mechanical, that is polythene sheets. So covering the water surface area by means of a polythene sheets, you can reduce the evaporation losses to some extent. So next is, the third method is the chemical that are used to reduce the evaporation losses. Generally, cetyl alcohol is generally used to reduce the evaporation losses in case of a reservoir. So this cetyl alcohol is a monomolecular compound. It will allow the rain and oxygen to enter inside the reservoir, but it will not allow the water molecules to escape from the reservoir. So when you spread a thin layer of cetyl alcohol on the water surface of the reservoir, so it is pervious to the oxygen and the rain or the precipitation, but it will not allow the water molecules to escape. So to some extent, you can reduce the evaporation losses. The only disadvantage of this method is, if there is a blowing wind, so this chemical will be washed away, so by the blowing wind. So that is only the advantage. About 1 kg of cetyl alcohol is required to cover an area of about 100 kilometer square. So when you apply the cetyl alcohol, a thin film is formed on the water surface. So thereby you can reduce the evaporation losses. Now you can see here, in some of the cases, you can cover with the polythene sheets. And here you can see, by straightening the stream channel. So here it has some bends and curves. So by straightening the stream channel, so the velocity of flow increases. Thereby, you can reduce the evaporation losses to some extent. And also you can see by growing trees, so generally on the periphery of the reservoir, on the periphery of the pond. So it acts as a windbreaker. So thereby you can reduce the evaporation losses. And also you can see here a thin film of cetyl alcohol is spread over the exposed area, water surface exposed area. So thereby you can reduce the evaporation losses to some extent. Next is, we have discussed the various losses of precipitation. The first one is the interception loss. The second one is the infiltration losses. And the third one is the evaporation losses. And the fourth one is the soil evaporation. So the next major loss is the evapotranspiration loss. So evapotranspiration losses is nothing but evaporation from the irrigated crop land and the transpiration from the plant leaves. So both put together is called as the evapotranspiration or evapotranspiration losses. So what is evapotranspiration? It is combination of two separate processes. One is evaporation from the wet soil surface in case of an irrigated land, and the transpiration process from the plant leaves. So both put together it is called as evapotranspiration. So the term evapotranspiration is also called as the consumptive use. It is also called as the consumptive use, is also used to denote this loss by evapotranspiration. So generally in the examination, either you may be asked, what do you mean by evapotranspiration? What do you mean by the consumptive use of water? Now, evapotranspiration is divided into two parts. One is the evaporation, the other one is the transpiration. So evaporation from open water surfaces and evaporation from soil and evaporation from the forest vegetation, and transpiration is nothing but the water escapes to the atmosphere through the plant leaves. So now, introduction. Evaporation is movement of water to the air from sources such as soil, canopy, interception, and water bodies. And transpiration is movement of water within the plant and subsequent loss of water as water vapor through stomata or plant leaves. Now, evapotranspiration, the total amount of water lost in the atmosphere to the atmosphere of water vapor into the atmosphere from surface of soil, canopy interception, water bodies, as well as from the plant leaves is called as evapotranspiration. Now we can measure the rate of evapotranspiration. So these are the units of measurement. The evapotranspiration rate is normally expressed in either millimeter per unit time, millimeter or centimeter per unit time. The time unit can be an hour, or it may be a day, or it may be a month, or it may be a year. So the rate of evapotranspiration, the rate expresses the amount of water lost from a crop surface in unit of water depth. How much amount of water has been supplied to grow a particular crop. Now, these are some of the difference between evaporation and evapotranspiration, evaporation and transpiration. So transpiration is nothing but physiological process and occurs only in plants because plant cells require air and water for its photosynthesis process. So water will be consumed through plant roots, and living cells are involved. Water moves through the epidermis. Various processes like vapor pressure, osmotic pressure, diffusion involved. So, and it depends upon the absorption of water from the soil. So generally, the plant roots will absorb the water from the soil. So next is formation of vapor continues for some times even after the saturation of the air. So evaporation is physical process and occurs in case of the water surface area. Both living and non-living and any liquid can evaporate. Not much force is involved. It continues as long as water is available on the surface. Evaporation stops when the air becomes fully saturated. Next, factors affecting evapotranspiration. So these are some of the factors which directly affects the rate of evapotranspiration. The first one is the environmental factors. Second one is the plant crop factors, and third one is the geographical factors, and the fourth one is the soil factors. Now, so the environmental factors. Now you can see this figure. So here what are the environmental factors like temperature. The warmer the temperature, it is more the evapotranspiration. So humidity, higher humidity means lower evapotranspiration. Especially in coastal areas, you have more humidity, hence the evaporation will be less. Whereas in the in the arid areas, the temperature is high, hence the evapotranspiration is more. And also the wind speed, more is the speed, more evapotranspiration. Next is the color of the surface, that is lighter color reflects heat away, so there is less evaporation. And also water available, less water means less evapotranspiration. That means if the surface area of the water exposed is less, obviously the evapotranspiration will be less. Now, the plant crop factor. So first factors which affects the evapotranspiration is environmental factor. The second one is plant crop factor. So what is the type of vegetation cover in that particular area? And it also depends on the leaf shape and size, and also the type of plant grown. The type of plant grown in particular area, because some plant requires more water and than the other, especially the rice crop, right? Rice crop and sugar cane, it requires large amount of water. Hence, the process of transpiration, the amount of water lost to the atmosphere through transpiration will be very high in case of rice and sugar cane crop. So it also depends on the plant crop factor, and it also depends on the geographical factors. The evapotranspiration rates are also dependent upon the geography of an area. That means the latitude and the climatic condition in that particular area. Regions on the globe with more solar radiation experiences more evapotranspiration. Evapotranspiration rates are also higher in areas with hot and dry climate. That is, in arid region, the evapotranspiration losses are high, and obviously evapotranspiration and evaporation is less at higher altitude. So this is also one of the factors which influence the evapotranspiration. So next is the soil type, the type of soil or the soil factor or the soil characteristics, soil capillary characteristics, that is the hydraulic conductivity, and the water table depth, how much, what is the depth of water below the ground surface, water table. If it is very near to the ground surface, then obviously the evaporation loss will be high. And the soil moisture content, the soil moisture content in a given soil. So it also, when the soil is lacking moisture, the plants begin to transpire less water in an effort to survive. So this in turn decreases the evapotranspiration. So now here you can see here, it is a dry soil, and hence the plant will transpire less amount of water into the atmosphere. So evapotranspiration also depends on the soil factors. Next is the consumptive use. Consumptive use is nothing but it is the evapotranspiration. What is the amount of water lost to the atmosphere through the process of evapotranspiration, or it is also called as the consumptive use. So consumptive use is nothing but quantity of water required by plants to meet its evapotranspiration requirement and to meet the metabolic activities. So here it is given by an equation. So Cu is equal to E plus T plus Wm. So here it can be generally written as Cu is equal to E plus T, since for evaporation and transpiration it is about 99%, and water required for the metabolic process inside within the plant cell, it is about 1%. So hence the equation can be rewritten as Cu is equal to E plus T, where E is the evaporation and T is the transpiration. Now, the factors affecting the consumptive use, one is the surrounding climatic condition, and the second one is the type of crop grown in that particular area, and also it depends on the soil characteristics, and also the management. Management means the methods of irrigation that has been practiced in that particular area to supply water to the crops. And you can see the climatic factors are the solar radiation, the temperature, mean and maximum temperature, minimum and maximum temperature during a day in that particular area, and the humidity, percentage of humidity in the atmosphere, and also it depends on the wind velocity and any precipitation. Any precipitation takes place during that process, during the growth stage of the crop. And the crop factors are the number and size of stomata, and the opening and closing of stomata, and the rooting depth and its pattern, and duration of the crop, because some crop requires more number of days from its sowing to its harvesting, and also plant architecture and plant pattern, the type of crop that you have grown in that particular area, and also the different stages of growth. So initially, in the initial stages of growth of the plant, it requires more water. As it attains the maturity, the quantity of water required by the plant goes on reducing, hence it reduces the transpiration. So next, soil factor, it depends on the water holding capacity. So this mainly depends on the porosity of the soil, and also the soil water depth. So what is the saturation, it is the moisture level in the soil, and also infiltration rate of that particular soil. So if the soil surface is impervious, obviously the rate of infiltration will be less. And if it is a sandy soil, so the rate of infiltration will be very high. Next is the management factor. That is the time of sowing a crop, then applying the fertilizers, then the mulching. Mulching means covering the plant with some leaves so that the evaporation and transpiration losses can be reduced to some extent. Now, necessity of consumptive use of water. So why this evapotranspiration is very useful. Plan the crop pattern for a particular locality. So depending on the estimation of this consumptive use, we can select a particular crop in that particular area. And also it is required to design a irrigation project, the type of irrigation to be practiced in that particular area. And it is required to determine the quantity of water to be released from the reservoir or from an irrigation project. And also in Kharif season, the consumptive use is less compared to Rabi season. So these are the two main crop seasons. One is the Kharif seasons, the other one is the Rabi season. So Kharif season, the crops are sown in the month of June and it is harvested in the month of September or October. Whereas in case of Rabi, the sowing is done in the month of October, November, and the harvest is done in the month of January, February. So there are two major crops, and in case of Kharif crops, since it is sown in rainy season, the water requirement will be very less when compared to the Rabi season. Now, types of evapotranspiration. So there are three types of evapotranspiration. The first one is the potential evapotranspiration, that is abbreviated as ETP. Next is the referential evapotranspiration, ETO. And third one is the actual evapotranspiration. What is the actual evapotranspiration? So which is nothing but the consumptive use. Now, potential evapotranspiration, it's also called as PET, is sufficient moisture is always available to completely meet the needs of vegetation, fully covering the area. Thus, resulting evapotranspiration is called as potential evapotranspiration. So in any case, sufficient moisture will be always available to meet this evapotranspiration requirement. So it is called as the potential evapotranspiration. Next is the actual evapotranspiration. It is the quantity of water that is actually removed from the surface due to the process of evaporation and transpiration at a particular locality and at a particular time. So it is nothing but the actual quantity of water consumed by the plants, and also the evaporation from the soil surfaces is called as the actual evapotranspiration. So the time is running out. So I'll continue in the next class. Hello. So please mark your attendance in the chat box. You have any clarifications or any doubts? Anyone? Okay, anyway, the time is running out. I'll stop the session.